Hello everyone. How are you guys doing today? I'm doing fine, thank you. Before I start my lecture, I should show you where to submit the homework. So when you go to our BRIGHTSPACE, you see the homework tab on the top. You can click on that. And then for now, we have only one homework. Oh, let me go to student view. So click on the homework tab. And then you see, if you don't have the book yet, I posted the questions for you here. And I also mentioned which number you should do for homework 1. And when I said submitting one PDF file, I meant however many pages you have, put everything together into one PDF file and submit. I saw someone submitted 5 PDF files. Why I'm saying one single PDF file? If you're submitting 5 PDF files, please don't do that from next time. Convert all the PDF files into one single PDF file so they can upload into one file. So I don't have to click on back and forth to see which questions you did. I can simply scroll up and down to see which questions you did. Okay, so from now on, please do that.
So I see here it says due today, but then it says available until September 8th.
Because some people still are registering or switching classes.
So it's due September 8th at the latest.
Yes.
Okay.
Am I able to just screenshot it like that, or does it have to be a PDF?
PDF is better. This only accepts PDF file. So to submit, you just have to click on the title. And then to see the picture bigger, you can click here. And to upload, you simply go here, upload button, and then upload from wherever you have used you stored your PDF file. Okay, and then submit. That's all you have to do. Okay. It doesn't get bigger. If it doesn't get bigger, probably you can just zoom in. Can I zoom in? It's a bad idea. Oh, cool. Thank you. So if you want to see it bigger, all you have to do is click the right, click on the right side, and then open in a new tab. It's okay. And then for new homework, you're going to see those below one under another one. Okay. So for next week Monday, we don't have any class, but if you have other Monday classes, you have those classes. For us, we don't have a class. And so the next homework, what you're going to do today, it's homework due will be next week Friday, next week Wednesday midnight. Okay.
And I'm sorry to interrupt. It says here question 1, 2, 4, 5. So you're not asking them to do all of them?
No.
Even though it's showing all of them?
I cannot just crop one piece by piece. It takes time. So I just posted everything on this page, but they have to do only those questions.
Oh, okay, perfect.
Any question?
I saw in the lecture last week that there were department recommended questions from this. Can you put those in the homeworks as well and indicate that they're not required?
Okay, I'll do that on next homework. And also, if you missed any class, you can see all these classes on the left panel. It says class recording. You can click on class recording and then just click on the playlist. You'll see all those classes. I'm teaching the same class twice, so you're going to see both classes.
And the recording, is it a recording only, or it also shows the slides?
Slides.
Both.
It's like screen recording plus this, like whatever I have.
Okay.
I'm doing here, you're going to see everything there.
Thank you.
Anything else? For now, no. So any question? Comments? Complaints so far? No? Okay, so we are going to start today's lecture. So in our last class, we finished section 1.1, and today we are going to start 1.2, but 1.2 is a longer section. So we will not be able to finish everything. Based on whatever we covered today, I'm going to post the homework and then tell you, do questions, this, and that for next week. Okay? So we are starting row echelon form. Before that, we need to know some definition. In an augmented matrix, do you remember what is an augmented matrix? Who remembers what is an augmented matrix?
The equation and the answer.
The coefficient and the constant without any variables. So in that augmented matrix, a pivot or pivot entry or pivot point or pivot position is the first non-entry in any row after the matrix has been reduced to row echelon form. The specific location of this non-zero entry is called pivot position. The pivot position is an element on the left-hand side of the matrix that you want the elements above and below to be zero. So we have a augmented matrix, and once we are going to reduce that. Once you reduce that, every number that has mostly zero on the top or zero above and zero below, we call that the first non-entry. First non-zero entry on each row, we call them pivot number or pivot entry. For example, here in this matrix, we have row wise 4, 1, 0, and then 0, 2, 5, and then 0, 0, negative 3. So if you go row wise, 4 is the first non-zero number, so 4 is a pivot number. Then 0 to 5, 0 is a 0, so 2 is the first non-zero number. So 2 is our pivot number, pivot entry. In the third row, we have 0, 0, negative 3. So negative 3 is our pivot point here, pivot entry. So how do you select that? We select by picking the column with the most zeros in it. So whatever column you have, you see which column has the most zeros. We try to pick a number from that column to have our pivot entry. You may wonder why I'm talking about pivot. We're going to see why later. So for example, the first column, we have 0, 0, 4. We have 2 0 and 1 non-zero. So definitely 4 will be our pivot entry. We want that. Eventually, when you're going to reduce our matrix, then we are going to convert that 4 into 1. Then use a row or column only once. Pivot on a 1 if possible. So if you already see a 1 in a column where we have most zeros in it, then that is your pivot. That should be your pivot number. For example, here we have 1, 2, 0. 1 cannot be pivot because before 1 on the first column, we already have a 4. So even though we have 1 in the column, but it cannot be pivot. Never pivot on a 0. You cannot say 0 is a pivot number. For example, our second column, the second row and third row, they started with 0, but we cannot say 0 are our pivot numbers here. Never pivot on the right-hand side. We can only pivot on the coefficient matrix, not on the constant matrix. So even the constant matrix has 1 and then 0, 0, we still cannot say that 1 is a pivot because constant matrix doesn't have any pivot. We only do pivoting in the coefficient matrix, the left side of the augmented matrix. Oh, my mouth is so dry. And also, if you observe, I said here, pivot is the entry when you reduce your matrix to row echelon form. So what is row echelon form? A matrix is in a row echelon form if it satisfies 3 conditions. No laptop in the class, please. Hey, no laptop. Close your laptop. Thank you. You are here only for 1 hour and maximum 15 minutes. So please don't use any laptop, any phone. Just listen to me. And then you can use whatever you want to use after class. Okay, so how do you know a matrix is in raw echelon form? If you see these three conditions satisfied, then it's in the raw echelon form. So on the top, I have formal way of saying everything, and on the bottom is non-formal, normal way of saying things. For example, the first condition is all the pivot entries are equal to 1. So in our last example, if you notice, we have 400. So this matrix is not in raw echelon form because the 4 has to be 1. So if you have a pivot entry, you want the pivot entry to be 1. Then the pivot entries sit on a staircase pattern. It means if you observe this matrix, the first one is 1 and all the other entries are 0. If you observe here in this column, this is non-zero, but it's not a pivot because in row, it's not the first entry. We want row-wise the first entry. So in this column, if you observe the second row, we have 1, 0, 0. So 1 is a pivot point, pivot entry. And observe the number. If you go from here to here, it follows a staircase position. So all 3 numbers here are pivots because row-wise, they're the first non-zero entry. And that position is staircase. And then the third one is any row or rows that consist of only zeros at the bottom of the matrix. For example, here, this entire row consists of 0, so it has to be on the bottom of all the other rows. So if you have these 3 conditions satisfied, that means the matrix you have, it's in the raw echelon form. Why do you care? Because using the raw echelon form, we can easily solve for our variables. But we are going to reduce it more eventually, if possible. And then if you can reduce it more, we call it's reduced raw echelon form. But before that, let's look at an example. Here in the first example, we have row-wise 1, 4, 2, 0, 1, 3, and 0, 0, 1. If you observe, this follows a staircase, and all those numbers are 1, so it follows. It's in reduced echelon form. Sorry, raw echelon form. Example here. In this column, we have 1, which is pivot. Here we have 2 non-zero entries, but it cannot be pivot because in 1 row you can have only 1 pivot. So here we already have 1 pivot, so change that pivot. So this is just zeros. And here in this column, we have the first non-zero number is 1, and from here to here, it follows a staircase. So it's in raw echelon form. Similarly, column-wise, this is not pivot because row-wise, this is our pivot number. Row-wise, this is our pivot entry. So this column doesn't have any pivot, but from here to here, if you go, you have to follow a staircase. So it's in reduced form. Which is not in raw echelon form are this. Example, this one. 0, 1, 1, 0. It doesn't follow staircase, so it's not in raw echelon form. Here, we have all the zeros on the upper row, but the third condition says if you have all the zeros, it has to be at the bottom. So it's not reduced. And then here in this column, or even in this column, our first entry is 2, so it has to be pivot because we have 2, 0, 0. But 2 doesn't have a problem. We can have 1 or any number bigger than 1. Yeah.
This word is non-zero.
Some book says pivot doesn't have to be 1. always. So this one follows staircase. So it follows our second condition. Third condition doesn't seem so clear. So yeah, according to this book, it's not in reduced, it's not in rational form because we want all those pivots to be one. Especially this 4 has to be 1 because we can easily make this 4 into 1 by dividing by 4. So when you can reduce more in easier way, it's not in rational form. So these 3 in echelon form, this in not rational form. Now let's see. But the first metric doesn't satisfy condition 1, which is all the pivot entries has to be 1. Well, it's kind of confusing. Some book says you don't have to have 1 to be pivot. For example, here. Look at this. This is pivot, but this is not 1. And also this is pivot, but this is not 1. It's confusing sometimes. But if you want to have a row echelon form, definitely in row echelon form, we want all those pivots to be 1. That's the main idea. Why it's 1? Because these are coefficients, right? So when you try to solve for a variable, you want no coefficient in front of the variable. You want x1 equals something, x2 equals something. You don't want 2x2 equals that, and then what is x2? We can figure that out, but we don't want that. That's why we want to reduce our matrix so that we don't have to reduce later again. Now, we have row echelon, but we can do more with the row echelon. We can reduce it more sometimes. When you can reduce it more, we call it reduced row echelon form. It means the matrix you're going to get now, it will never be reduced. It can never be reduced anymore. So it's the final reduced version. We cannot reduce it anymore. So how do we know when a matrix is in row reduced row echelon form? The first condition is it has to be row echelon form. It means all the 3 conditions we have for the row echelon form, it has to follow all the 3 conditions. And then 1 must be a leading coefficient. Okay, so any pivot you have, it has to be 1. So in reduced row echelon form, we have to have 1, and only row echelon form, it doesn't have to be 1 always. And then the third condition, each leading 1 is the only non-zero entry in this column. So every 1 below and above, they have to have 0. So in one column, we can have only 1, 1. Then it's in reduced row echelon form. For example, here, this is our original augmented matrix. When you reduce, you get row echelon form. So this is a row echelon form, and if you observe, we have 1, 1, 1. All of these are pivot points, but it's not reduced row echelon form because we can simplify this even more. So when you simplify this even more, this becomes 1, 1, 1 diagonally, and everything else becomes 0. So this is the last augmented matrix you can have from the original augmented matrix. So this is reduced echelon form. It follows all these rules from here. All the pivots are 1, and also all the non-zero entries are all the non-zero entries are a number. All the non-zero entries on the left side. And then one more condition is that in each column there has to go into 1, 1. Cannot be more than 1, 1. So we have only 1, 1, 1 here, only 1 here, only 1 here. And in the third column means we have more infinite solution. So in this class, we are going to do a lot of reduced echelon form. Why? Because anytime you're trying to solve a system of equations, you definitely want your final matrix to be in reduced echelon form. Clear? Any questions so far? Okay, so now which of these are in echelon form and which of these are in reduced echelon form? would like to answer for A? Give me your thought. What do you think? You don't have to be correct. Reduced. Why do you think that?
Rows, the zero matrix one block.
So we have two pivots, actually, yeah, two pivots. And then the last row is zeros, and we cannot reduce them anymore because here we have all the zeros, here we have all the zeros. So this is cannot be reduced anymore. There's no way to reduce it. So this is reduced row echelon form. Who would like to tell me your thought about B? You don't have to be correct. Just let me know what do you think.
It is not echelon form
Not row echelon form. Why do you think that?
because the leading pivot in the first row is not one.
Good. We have a negative. We definitely don't want negative in our matrix. So we can reduce that. So it's not in row echelon form. Because row echelon form says, well, at least you have to have some reduced. But this is not reduced at all. Also here. Also you can reduce this one. 2 and 1, we can reduce them. We can subtract them. So this is not in row echelon form. And if it's not in row echelon form, it's definitely not in reduced row echelon form. How about the third one?
It's not in reduced form.
It's not in reduced form, definitely. We can reduce, when you subtract these two, we can definitely reduce them more. But how about row echelon form? Is it in row echelon form?
Yeah, the leading entries are 1.
Leading entries are 1.
Not sufficient.
True. Not because these two, we can reduce these two, right? If you multiply this by -2 and add this, it becomes 0. So the last entry, the last row actually can be all zeros. So my opinion should be not reduced, reduced row echelon form. Let's see. I didn't have the answer. Oh man. Oh no, I do have the answer. Let me check. Yeah. The first one is reduced row echelon form. Then we have not reduced, not row echelon, not row echelon. So sorry. It's okay, no problem.
Sorry.
Oh, wait, Professor. It's my thing. Okay, thank you. Did you get my other one? Yes, I did. Okay, thank you. Why I sent it to you, that's fine? Yes. But you can actually upload directly on BRIGHTSPACE instead of sharing them. Okay, we have a few more. What do you think? Are they in row echelon form, not row echelon form, or are they in reduced row echelon form? Let me take the attendance so I can pick my volunteers. And it is 90. Think about that for a moment. Brandon C. Joseph. Is it Joseph or Joseph? Joseph. Justin. Zibran. Hibu. Is it Hivu?
No.
Oh, sorry. Shavu.
Yes.
Shavu. 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 Michelle. Michelle. Jack. Ashif. Is it Ashif or Asif? Ashif. Darius.
Here.
Fire. Winston. Abigail. Jane. Emily. Panar. Christine. Edison. Maisha is here. Brandon. Elvin. Chapayo. Chapo. Alexander. Shitila. Wen Xuan. Kailun.
Here.
Okay. So, any volunteer for this one? Go ahead. Chapo. Chapo. Chapo.
Right?
Sorry, not Chapo, my bad. Go ahead.
It's not Rochelon.
Not rational from. Okay, why not? Why do you think it's not?
It was pivot. I think you can fit one.
You cannot choose two as a pivot because in one row you can have only one pivot. So in the first row you already have one as a pivot.
Right. But then the stair step is 0.
So you can go 1 to from top 1 to bottom 1, no problem. So what did you say? It's not rational form or it is rational form?
I thought it has to be a non-zero entry for the stair step.
If it's possible.
Well, it's not a manual. Okay.
So for example, here our second column doesn't have any entry.
Right.
So it cannot go staircase directly, but you can skip a step.
Oh, okay.
So skipping step is possible. So what did you say? What is the answer?
Oh, I said it wasn't a Rochelon, but
It's not in raw echelon.
I didn't know you could skip the.
I think it is in raw echelon because column wise we have only one non-zero entry, and here row wise is only our pivot. So if you look at the second row, row wise this is our pivot, and here the condition was what? We have to have 1 and then staircase, and if you have zeros, I forgot all the conditions already. Zeros at the bottom, staircase, and pivot 1. So we don't, no, come on.
It also has to be like a diagonal.
Diagonal happens when you have square method, like row and column are same. Here we have 4 columns but 2 rows. Okay, so you think it's not raw echelon, but I think it is in raw echelon because row wise we have 2 pivots and both of them are 1. We have no 0 entries at the end. We don't have anything, and we can reduce it more to get reduced echelon form. We can get rid of these 2. So I believe this is in raw echelon form, but not in reduced echelon form. But you're going to check the answer later. Okay, so raw echelon form or raw echelon form, which one? B. B is easy. Why not? Yes. We have to have all the zeros at the bottom. So if it's not on the bottom, it's definitely not in row. So we all agreed it's not row echelon form. How about C? Is it in row echelon form or reduced row echelon form?
There's the last row has all the
Mm-hmm. And then if you can reduce it more, then it's only row echelon form. You cannot reduce it anymore, then it's reduced row echelon form. So which one? Is it only row echelon form or it's in reduced row echelon form? It's reduced because the only thing we can change is 3, but actually we cannot do anything with the 3. So it's reduced row echelon form. We have nothing else we can do here to simplify anymore. So definitely reduced row echelon form. D, who would like to do D? Do you want me to call you? Winston. Any other subject?
I agree.
Agree? Me too. Reduced row echelon form. Because we have only one entry and there's nothing else we can do here. Definitely end of our matrix. We cannot do anything. Okay, E. Brian. Sorry, Brandon.
No, it's not.
Not row echelon form. Why not?
The 3 is the first.
We want 3 to be 1, so it's not here. And yeah, there's only, if you find only one reason, at least one reason, you'll find. So we are saying we want that 3 to be 1, so it's not row echelon form. But if you follow some book would say, well, it's row echelon form because we don't care about what number we have as long as we have first non-zero, first non-entry number, first non-zero number. First non-zero entry is first non-zero number could be first non-zero entry could be any number. Some books says. So I would go with not echelon form.
I have a question. So wait, you reduce that by subtracting the bottom equation by
We
the
can
middle one?
definitely make this 1 by dividing by 3.
Oh, you find that, okay.
And then so it will be row echelon form. And then when you have row echelon form, we can reduce it more because we can get rid of this and we can get rid of that. And also we can get rid of that. So when you can reduce it more and more, it's not in reduced form. But at least you have reduced form, then at least you have some reduced form, then it's in row echelon form. The last one.
I would say not row echelon form,
Why not?
because it doesn't follow the script.
Good observation. It looks like it's in row echelon form, but we have to swap these 2 rows because it doesn't follow staircase. We have third one entry 1 here and second one here. So we want the second one here and the third one there, so that we can have a staircase. So it's definitely not row echelon form. Now let's see the answers. Row echelon form is ACD. So row echelon form, row echelon form, row echelon form. And reduced row echelon form is CD. So reduce. So yeah, we are correct. The only thing we had doubt about A, he said it's not row echelon form, but I said I assume it's echelon form, and it is in row echelon form because 1 and 1, or pivot entries are 1, and it follows the staircase. Even though we have to keep a step, but still from left to the right you're going. Any question on this? No. As long as from one pivot point to go to the another pivot point to the next pivot point, you go from left to the right, you're fine. For example, here, it's not static because they're going in this direction, greater than sign direction. So if you have one here and one here, then it's good. Or from here, like see by these is possible. From here it's possible here, because from here to here you want to be left, straight, and kept going right. So you have to go to your left to the right. You cannot go right and then move back to the left and then go to the right. You cannot change your position. You have to go in a smooth left to right direction. Any other question? Now your solution matrix. So if you have a row echelon form, we can already figure out our solutions. You have to work a little bit, but you can at least get to your solution. If you have reduced echelon form, you can see your solution directly. So if the row echelon form of the augmented matrix contains a row of the form below, then the system is inconsistent. For example, here, remember the two types of solution we talked about last class. One is consistent and one is inconsistent. Do you remember talking about that? So consistent means it has a solution. Inconsistent means it doesn't have a solution. And when you're consistent, there are two choices. Either you have unique solution, means each variable has one solution, or you have infinite solution, means whatever lines or however many lines you have, all of them are the same line. So for consistent, you have two types. For inconsistent, there is only one type. How do you know something is inconsistent? If you have all zeros for the coefficients, but there is a number for your constant. So you have none of the variable exists, but suddenly you have one here. So it doesn't make sense. Like 0 is not equals to 1. So it doesn't make sense. Since it doesn't make sense, so we have an inconsistent solution, means we don't have any solution. The solution doesn't exist. Because look, all the coefficients are 0, means we don't have any more variable. Since we don't have any variable, we cannot have a solution for no variable. So basically saying we have one solution for no variable. What does it mean? That mean? And when we have unique solution, we have a triangle. This type of triangle, we have on the lower side of the triangle is 0, and on the upper side you have a solution. Upper side you have numbers. So we have any solution for that. For infinite solution, I don't have the format here, but when we bump into infinite solution, I'll let you know these are infinite solution. Okay, so now for each case, indicate whether the corresponding linear system is consistent. If the system has a unique solution, then find it. So basically, you're saying that, do you have a solution or you don't? If you do have a solution, what is your solution? A. Any thought for A? Inconsistent, because no variable exists, but you have a solution for no variable. Doesn't make sense. So for A, we have problem here. So no solution. Any thought for B? Any volunteer? So let me do B. First of all, the third row doesn't have any problem. We have coefficient 0 and constant 0. So there is no information you can get from here. So we ignore this one. If you look at the second row, we have 1 for the coefficient and -1 for the solution. So this 1 is the coefficient for what variable or which variable? x2. The columns are the variables. So we have x1 here and x2 here. So the second column is still, second row is telling us that x2 is -1. And that's how we write down the solution. We start from the bottom. Oh, this is the best substitution. So we start from the bottom, we found that x2 is -1. And then we go the top row. The top row, we have 1x1 plus 3x2 equals 1. This is what the top row is telling us. 1x1 plus 3x2 equals is 1. But what is x2? -1. So we have to find what is x1. We substitute x2 with -1, and we get x1 minus 3 is -1, so we have to add 4. Oh, sorry, we have to add 3, sorry. We have to add 3. So what is our x1? How much? 2. So our solution is x1 -1, x2. Sorry, x1 is 2 and x2 is -1. And this is what they're saying. Did I make a
Where does
mistake?
it become x1 plus 3x2 equals 1, and then the solution on the way below is negative?
Because I made a mistake. Thank you. Good catch. See, that's why I had 4 in my mind, because I saw it 4, but I wrote it. Oh man. So yeah, you can easily replace it. So x1 plus 3, x2 is 1, but x2 is -1 from the second row. You substitute, so for the missing variable. That's how you find solution. Now, who can do C? Volunteer for C.
Bottom row, fine. Put the rows in.
So it doesn't give any information. So it doesn't need that. How about this information? What is telling us? X3 is 3. And then what is the top row telling us? Minus 2x2. So let me do it here. Let's see. x1 minus 2x2 plus 4x3 equals 1. But you already know x3. So x1 minus 2x2 plus 4 times 3, 12. And then we can solve for x1, right? So if you want to solve for x1, you have to move everything else to the right side. So we need to add the 2x2 and subtract 12. So subtract 12, add 2x2. We get x1 is 2x2 minus 11. So this is our x1. But then we have a problem, right? We don't know what is x2. So what we say here is, well, x2 could be anything. So x2 is x2. It's unique, it's infinite. Based on x2, we can figure out x1. So x1 depends on x2. So we have infinite solution, right? Yeah. When you cannot solve for one variable, it means you have infinite solution. So we have x3 is a single number, but x1 and x2, they cannot be one solution. x1 depends on x2. And x2 is what? Anything. If you pick x2 is 1, then we have 2 times 1 minus 11, 21. you can pick x2 is 0. We have 2 times 0 minus 0, negative 11. So how many solutions we have here? Infinite solution. We have infinite solution, but for infinite solution, each variable has their individual equation. Like x2 is the most free one. x1 is dependent on x2, and x3 is most stable one. It doesn't change. So x3 is fixed, but x1 and x2, they're moving everywhere. Question?
Would we not be able to solve this by plugging in 2x2 minus 11 4 minus 1?
Here. So you got this equation from here.
Oh,
Like this doesn't exist if this doesn't exist. So if you want to substitute that back in, it doesn't make sense. Any other question? A good observation. If you could do that, we can get x2. But then why is x1? So see, we have so many weird types of scenario. Okay, volunteer for D. Who would like to try D? So you're playing hard. You want me to call you? Abigail. Oh, you already did. Never mind. Emily. Emily? Emily, help me with D, please. It's asking to give them the solution. What is x1, what is x2, what is x3? So the first column is x1, then the second is x2, the third is x3, and then the last column is the solution. So can you tell me what solution you see here? You can't even see? Okay, for next class, sit in the front. Go ahead. Thank you. So definitely we start from here. This is easy. X3 is 2. X2 minus X3 is 3, but you already know X3 is 2, so X2 minus 2 is 3, we add 2, so what is X2? 5. And now what this tells you?
X1 minus 2x2.
Minus 2x2, but x2 is 5, so let me just put it here. And then plus
Plus 2x3.
2x3, but x3 is 2, equals negative 2. So x1 minus 10 plus 4 equals negative 2. Minus 4 plus 10, minus 10 plus 4 is negative 6. So I'll do it here. X1 minus 6 is negative 2. You add 6. So x1 is how much? 4. So we do have a unique solution. So when you write down, we should write down this. So x1 is 4, x2 is 5, and x3 is 2. And then box all of them. So this system equation has a unique solution. It's in row echelon form, but it's not in reduced row echelon form. That's why we had to solve for each variable individually. When you have reduced row echelon form, we don't have to solve each variable individually. Most of the time. The easy one, the next one. Why not?
Because on the last row, zero equals 1.
Exactly. No variable equals 1. What does that mean? We have no idea. So no solution. Last one, F. You're going to see them in the exam. So it's a good practice if you do it here. Edison. Let me get a page. Yes. So this tells us x3 is 2. Perfect. What this tells us. 2. 2 x3 is 7. But you already know. Three.
Top equation. X1 minus
X2.
Plus
3.
3
X3.
And then
8.
8. Substitute the variable of that.
X2 is 2 and X3 is 3.
2.
X2 is 3. Sorry, my bad. Yeah. X2 is 3 and X3 is 2. So we have X1 minus 3 plus 6 equals 8.
Minus 6.
X1 plus 3 equals 8. So what is our X1? 3 plus what is 8? 5. So we write down the solution. X1 is 5, X2 is 3, and X3 is 2. So this system has unique solution. Even though this F looks like this C here, but C has infinite solution and F has unique solution. Any question on any of these?
So by strictly triangular system, does that mean where there's the pivots are
All those non-diagonal entries are 0 on the downside, on the below side. Below the diagonal, you have all zeros.
so it could skip a step if everything below is 0. Okay. And then when we answer like for back substitution in the homework, is like this format at the top right, what you're looking for.
So solve individually each variable starting from the bottom row, and then at the end just put them together. So it will be easier for me to check. So I can check if all of them are correct, then I'll check, you get points. If one of them is wrong, it just gets wrong. It's easier to grade that way. And also this question will be in the exam. So I'm going to ask which of these in row echelon form, reduced echelon form, and then find the solution from these reduced matrices. So I already gave you 2 questions for the exam. Okay, the definition. The process of using row operations 1, 2, and 3 to transform a linear system into one whose augmented matrix is in row echelon form. That process is called Gaussian elimination. So by following the 3 rules, if you reduce a matrix to row echelon form, you did Gaussian elimination. But when you can reduce even more to get the reduced echelon form, we use Gauss-Jordan elimination. Okay, so if you just reduce, it's Gaussian elimination. But if you reduce, fully reduce, then it's Gauss-Jordan elimination. That's the two name of the process, so we have to reduce them. How Gauss-Jordan is different than just Gauss elimination. Both Gauss and Gauss-Jordan eliminations are somewhat similar method. The differences is that in the Gauss elimination method, the matrix is reduced into upper triangle matrix. It means we have diagonals, number, and all zeros. So this is Gauss elimination, which is only row echelon form. But if you use Gauss-Jordan elimination to get the reduced row echelon form, then you get a diagonal matrix. Means you have only diagonals number. Here is 0, here is 0. So this is what it looks like. Okay, now you cannot reduce anymore. So you have all the non-zero entries on the diagonal, and above the diagonal, below the diagonal, you have all zeros, which is completely reduced form. But in Gauss elimination, you have numbers above which can be reduced later. Okay, that's how you can identify which format you have. Did you use Gauss-Jordan, or do you have Gauss-Jordan, or do you have only Gauss elimination? Solve the following system of linear equations using the Gauss elimination or the Gauss-Jordan elimination. So either you just reduce it, or you just do the complete row reduced echelon form. So we have a big matrix. They didn't tell us what type of matrix is this, but since they're telling us to reduce it, anytime they tell you to reduce a matrix, it definitely means you have an augmented matrix, not coefficient matrix. So in this augmented matrix, how many variables do you have? Good job, 4, not 5. Why not 5? The fifth column is the answer, not answer, constant. So we actually have an invisible line here. Make it visible if it makes your life easier.
So the leading one is a 1 for both 1 and 4. So would it matter if you switch 1 and 2 or 1 and 4?
So the first problem, we see that we have 0 here, but we have 1 here. So you can switch either the second row or the fourth row. You can do one of them. If changing to 2 will take 2 steps to reduce. So we want this to have the format 1 0 0 0 something 0 1 0 0 something 0 0 1 0 something, and then 0 0 0 1, and then we have the solution here. If possible, we want to change this matrix into that matrix, if possible. So what you do, remember the 3 things you're allowed to do? You're allowed to swap 2 rows. So first step, we can swap rows. Either you can swap with the second row or the third or the fourth row, because we want that 0 to be 1. So the process they're telling us that switch 1 and 2. Just switch them, swap them. And then another operation is about another valid operation is that you can multiply by any number. So here they multiply by 1/3, just dividing by 3. And then another operation is that you can multiply one row by number and then add with another row. So this is another allowed operation. Or you can subtract. So here are all the steps. First, what they are doing is they switch row 1 and row 2. So when you switch them, you get the second row goes on the top row goes on the second. So we have 1 here to satisfy this one. Now, when you reduce, it's better to reduce column wise. That means after we solve this problem, now we run 0 in the second position, which we already have. So the second row, the second position is 85. Now the third position we have 0. But the third position we have 2. So what can you do so that the 2 will become 0? They are saying multiply the first row by 2, -2, and then add with this one. So if you multiply the entire row by -2, this 1 becomes -2, and when you add with +2, -2 plus +2 gives you 0. So the third space is secured. So you get here. And then when you do that, sorry, my bad, before I down here. So when you do that, we have only one problem, the last one. You can easily solve the last one if you subtract the first and fourth. So subtract the fourth row from the first row. Other way around. Subtract the first row from the fourth row. Then you have 0. So we have our first column 1, 0, 0, 0. And then we go ahead and go to the next column. In the next column, so they kept the first row unchanged. And so they're doing Gauss elimination, means they don't care about what numbers they have on the top of the diagonal. They want on the bottom of the diagonal to be 0. So if you want that, that means we don't care about what number we have. So there could be anything. The main idea here is that we want all the diagonals to be 1, and below 1, all the entries are supposed to be 0. Then at least we have a row echelon form. So by following that, we have here the 2 we don't care, and we already have 1 on the diagonal, and we have 0 below that. So these 3 things we are fine with them. That means our problem is -6. We have to get here that -6. So you can easily multiply the second column, the second row by 6, and then add with the fourth row. So second row by 6 and add the fourth row. Now we have the second entry on the second column. The last entry in the second column is 0. So we are happy. We have 1, 2, 3, 4, 5 0, and we already have 5 0 here. That means the only thing we now want is that 0 on the third column.
Just to clarify, so when you're doing, like say for step 4, R4 plus 6 R2, you don't ever change R2, right? It's just a multiplication.
So whatever you're changing, like they're saying, well, we are going to change R4, means row 4. How are you going to change? We are going to add the row 4, the current row 4, with 6 times row 2. So you multiply 6 times row 2, and then you add the last row, and that is our new row, so you get row 4. And then lastly, you can do 2 steps together, and then they'll give you 0. Well, it is 0 in the third position, but we want these 3 to be 1 divided by 3. And then for this one, you take one more step divided by 13, you get 1 here. So here we have row echelon form, and we can solve this easily. So this row echelon form gives us this equation. X4 is 3, X3 minus X4 is -2, and then this and that, and then you use back substitution to solve the rest. And you're using back substitution because we did not get reduced echelon form. We can reduce this more. When you reduce this more, we have to use back substitution all the time. With this, we are done for today. So I want our question. Which questions? Questions 2, 3. Question 1, 2, 3,
1D.
5. I want our 1, 2, 3, 5. So let me see which question I can assign you for next class. Here. Question 2, A to F. 3A only, question 4, A to F, 5, B and D only. Question 6, AD, you are going to do next class. And these are the solutions from the departments. 1 to 6, everything, including question 19. So 2, 3, 4, 5, do next week, Wednesday midnight. And next week, Monday, we don't have any class, but if you have other Monday classes, you have them. Okay? So see you guys again next Wednesday. What's the homework due again? Next Wednesday midnight.
Say this once. Working plan.
You're allowed to have 4 absences.
Okay, perfect. And I did submit my work already, so.
Cool.
And you said this, only this class next Monday will not have. Okay, great. Thank you so much.
I have a conference to go to, so
You have one?
I have a conference
Oh.
to, so I cannot be here.
Have fun.
Thank
See
you.
soon.
Bye, Miss. Thank you. Have a good day.
Mhm.
Sorry, I just have a quick question. Could you go back to the problem? Could you go back to the problem which is the possible?
The last one, sure.
But I need to.
Mhm.
I got a little confused about these parts, so.
So here we have row 4,
Mhm,
1, but we don't want 1 there. We want 0 there.
yeah,
Now, how can we have 0? If you subtract row 1 from row 4,
mhm,
then this 1 will turn into 0.
yes,
So 1 minus 1, 0, and then -4 minus 2, -6. So you're subtracting row 1 from row 4,
Mhm.
and that's your new row 4.
okay,
And then once you have new row 4, then you have one problem. We have 1, 1 here. Below this 1, we want all the entries to be 0.
Mhm.
So you have 1, 0, but we don't have -6 to be 0. We want -6 to be 0.
Yeah.
So in order to get -6 to be 0, they said, well, what you can do is you can multiply the second row by 6.
Yeah.
And then add with the 4th row and make this a new row 4th,
Mhm.
4th row.
Mhm.
So 6 times 1 is 6 minus, you're adding -6,
Yeah.
it becomes 0. And then 6 times 1 is 6 minus -6 is 0. So you have 0, 0 here.
Mm,
And then
okay.
if you do same thing, 6 times 2, -2 is 12, -12, -1 is -13.
Yeah. Okay, I see.
Mhm.
But,
So each time you're changing something, you should write it down next to the row.
okay,
Which row you are changing and what's the current row.
but, so this doesn't change, for example, if we do it here, we don't actually change row 2 at all, like, we don't multiply.
You
Okay,
do it on the side.
Okay.
You don't change it inside the matrix. You do it on the side, like 2 times row 2. So you multiply entire row 2 by 6, and then you add the row 4, do the math, and then put it on the 4th row.
okay, so we're only changing the one we want to change.
Mhm.
Okay, thank you.
Everything else stays same.
Alright, thank you.
No problem.
I just wanted to excuse myself because I came late today.
And I took that and then, so, Michelle.
Yes, I was dealing
Yeah.
with my daughter's school.
Oh, wow.
Yeah, it's her first time going to school. She's
Mhm.
3. So they kept me in the office until they figured it out. She'll be going to school tomorrow.
No problem.
Thank you.
Next Monday, we have no school. I mean, sorry, actually, it's no school. We have no class, but we have other classes.
Okay, thank you so much.
So, with this back substitution, I had one question. So it was like the homework.